So, good afternoon, everyone. Welcome to this week's installment of our UE Systems webinars. My name is Chris Hallam. I am the UK and Ireland manager for UE Systems, and joining me today will be our Global Director of IIoT Solutions, Blair Fraser. And today we're going to go through with you one of our latest systems in the world of remote bearing monitoring and lubrication. Now, for those of you that do not know us, UE Systems, we are a global manufacturer of ultrasound equipment, providing the equipment, support, and training for you to be self-sufficient in your plants. Now, a little bit of housekeeping before we start with this. This is being recorded and it will be uploaded to our YouTube channel. It is live, so please bear with us if we have any technical difficulties. Please feel free to use the question and answer function of this webinar. And if we can, we will answer the questions during the webinar. Any questions that we do not answer, we will get back to you at the end of the webinar. Okay, so that's enough from me. What I'm going to do now is hand over to Blair to share his screen, and then Blair to give himself a quick introduction and go through the webinar itself. So Blair, all over to you.
Yes, thank you, Chris. Yeah, thank you, everybody. Thank you for taking the time out of your day. Just a little bit of background on myself. I am the director of IoT here at UE Systems. I'm coming to you live from Canada, so over the pond, if you will. It's my morning here. So yeah, it's my pleasure to speak to you today and walk through the new feature that we have in the OnTrack system, which is called our Smart Lube. Now, you might have seen we have made a splash in the market on being able to monitor your bearings for their lubrication needs and health insights 24/7 using the OnTrack system. And now we've taken that a step further with our continuous innovation in integrating single point lubrication devices. And this is what we're gonna walk through today. And as Chris mentioned, I encourage you to ask questions. The reality is there is a lot of decisions and a lot of details that go into these systems, lube types, how to mount these things, exactly how does it work, all that kind of stuff. And we can't go over every single thing in an hour webinar. So I do encourage you to ask those questions, even if we don't get to it on this webinar in particular. We will make sure we address it, even if you have very specific applications. As we launch this across the globe, we've had people come back from use cases on everything from submarines to airplanes in the sky and anything in between. So we get a lot of interest in a lot of unique applications. So don't be shy to share those and ask the questions. So yeah, really what we've been able to do is use that prescriptive bearing monitoring. And what I mean by prescriptive is it tells you exactly what you need to do, right? And we've combined that with precision lubrication from anywhere, anytime. Now, unfortunately, as many of us are going to go back into lockdown and things like that, the value of getting the right information, the right time, and being able to act upon it is getting more and more important. And so why are we investing so much time or so much energy in our innovation around lubrication? Right? It's the same reason that many of you are using our technology for ultrasound guided lubrication, whether it's our 10,000, 15,000, or even our very specific grease caddies. They're because of this. Now, this is a study done by SKF, but it gets repeated by almost every bearing manufacturer and industrial organization that's out there. And what these studies come back and say is that lubrication is the leading cause of premature bearing failure. And the study by SKF said that over 80% of premature bearing failure is lubrication related. Now, any of us that are in the industry typically know that, we understand that, and we try to eliminate that the best we can. So when you look at these studies, and I encourage you, if anybody wants a copy of the study, more than happy, you can actually go to the SKF website and find it yourself, or we can send you a link. And when you go through that study, that 80% is broken down into 4 categories. So the first one is insufficient lubricant quantity. This is the one that we concentrate the most on, in my opinion, that we see our customers doing, right? And typically it's under greasing or over greasing. Now, if I look at industry, what I see more is we see more over greasing than we do under greasing. People just naturally go to over-greasing versus under-greasing. So I'm sure many of you have either in your facility or you have been through a facility that there is literally grease coming out of the seal of the bearing, right? But that one is also only 15% of that 80%. The next one is long time without renewing that grease. So while there still is a quantity of grease in that bearing, it has lost its properties. The properties why we select that right grease, it is no longer providing that defense against that friction, right? Then we get into two other ones. So unsuitable lubrication, right? So we've seen it, we've all heard about it, people using the wrong grease on the wrong bearing. It happens, right? And we've gone to great lengths to be able to prevent that from happening in terms of color coding our grease guns, our Zerk fittings, and things like that, right? But there's still, in most cases, there's still always a case for human error to happen. And the biggest one is lubricant contamination. Now, it depends which study you look at, because this number, I think the minimum would be 25, but we've seen it in different studies go up all the way to 40%. And this is really stuff that you don't want getting into your lubricant, dirt, debris, specifically water is a really bad one, causing that premature bearing failure. So when you look at this holistically, we want to make sure that we can reduce or even eliminate the impact that all four of these categories have, right? So this is really why the OnTrack and specifically the Smart Lube was born. And when I look at this industry, and I've been a long time partner of UE Systems and recently joined UE Systems this year, is I had the pleasure over the last 3 years to go out and really learn and spend a lot of time in this technology ecosystem, from large Fortune 500 technology companies to small two-people startups across the globe. And where I saw a lot of focus was in that predictive domain. Everybody, in my opinion, is racing to be able to detect a failure, right? I can detect this first, look what I detected. And we see it on social media all the time. Hey, look what we were able to detect, right? And it's a bunch of squiggly lines and things you don't understand, so you have to draw lines at it to say, look what I was able to detect, which I think is great and has a lot of value. But really, where we're trying to do, instead of detecting a failure, is trying to prevent that failure in the first place, right? And it goes back to that quote about an ounce of prevention is worth a pound of cure, right? Is if we just took a small fraction of the money we're spending on systems to detect an issue and spent that to prevent it in the first place, could we have a better reliability of that piece of equipment? So we designed the OnTrack to really focus on that proactive domain, but we also sit in that predictive domain with ultrasound being able to detect that early onset of that initial bearing failure. So what exactly is this Smart Lube? So it's a remote bearing monitoring and now with the Smart Lube feature, it's a precision lubrication system designed to significantly reduce the amount of time and resource required for optimal bearing lubrication. And really, it's that time and resource required, because a lot of you on this call are going to know the fundamentals or even more knowledge about proper lubrication. The reality is, I believe in industry, most of us are well trained around the fundamentals around lubrication. It's that we do not have enough time to properly manage, or in some cases, really baby each bearing. So when we designed this product right from the start, we almost did a reverse process. We said we need this solution to be simple, affordable, and open. So simple in the terms of, if we look at how ultrasound and particularly our equipment is being used in the marketplace, and the feedback we get is that it is relatively a simple technology out of all the condition monitoring technologies to be able to implement and get value from. So we wanted that same simplicity through the entire experience of the OnTrack. So, how you commission it, how you install it, and how you maintain it, right? Because at the end of the day, we don't want to put a system in that requires more maintenance than the bearings itself, right? And of course, affordability. So affordability is a big one. No matter how great your solution is at solving problems, there is always a tipping point between the cost and that value, right? Or could it even be perceived value? So we really want to disrupt the market, not only from a technology point of view, but also from affordability, because we understand the recent study I read, I think it was Plant Services Magazine, said the average plant or average facility, now this is across all industries, has 2,364 bearings, right? A very precise number there. And that's across all industries, so it's skewed either way. But that's a heck of a lot of bearings to manage, even if you're half of that, right? Even if you're 1,200 bearings or you're double that, right? That is a lot of bearings to be able to manage and to put this technology in. So that ROI needs to be there. And the other thing that we're going to talk about is the openness of the system. So no longer do technology companies try, or should they try, to own the ecosystem or own your data, right? We often say that data, or we hear data is the new gold, but the reality it's not. It's really insights is the new gold, and data is just that raw material. We need to get those insights. So what we want to do is give you the ability to send this data to whatever system that you can help transform this data into insights. So the OnTrack Smart Lube, it's really designed with 4 parts in mind. So the first part is the OnTrack Edge Analytic device itself. A lot of people refer to this as the hub. Okay, and what happens with this OnTrack, it is a 16-channel unit. I'll go into more details on how everything gets connected. We pair the OnTrack with our UltraTrack 750 ultrasound sensors. These sensors are really what's providing the value. They are listening to that bearing 24/7. Asking it, do you need lubrication? Do you need lubrication? Are you okay? Do you need lubrication? 24/7. Even when you can't physically be at the plant, it's asking that question every 24/7. And when we do start to lubricate, it's going to say, have you had enough? Have you had enough? Have you had enough? Right? So it's really, the system cannot be used without these, obviously, these ultrasound sensors. Now, what we've been able to do with the release last week was we've integrated single point lubrication devices. So what we can now do is when that bearing or the sensor is sensing that this bearing requires lubrication from anywhere, anytime, given the right security, you can properly and very accurately lubricate those bearings. Now, all this data is designed to go back to our UE insights. Now, I did say that this platform is open, so it doesn't have to. It is optional. Now, if you do want to use the Smart Lube feature, which means remotely lubricate your bearings, you do have to use UE insights, because that's where all the intellectual property, our decades of experience of using ultrasound for lubrication, is really programmed into UE insights. So all the user interfaces and things like that. So it is optional though. We've had customers send data to UE insights and to SCADA systems like Ignition, Siemens, building automation systems, CMMS systems, OSI Pi, Delta V, all those types of systems as well. So it is very open in terms of where you want to send this data. So some of the features is, I'll start here at 12 o'clock under the communications, is how do you get the data to the right people at the right time to make those informed decisions? So we have 3 options. We have Ethernet and Wi-Fi, which really depends on your, or relies on your network, which means we are going to be another node on typically an automation or kind of some process control network. And we're going to open up some ports and firewalls and send that information out, right? You know, it's typically standard, and we have mastered this game of going through those IT security questionnaires and encryptions and all that kind of stuff, right? And the third option, which we released with the original OnTrack back in May of this year, was the cellular option. Now, we knew this would bring a lot of value to our customers. But really, we're seeing this, I would say, you know, every 8 out of 10 OnTracks that we ship to our customers prefer cellular network, and it's for 2 reasons. One, it becomes very, very simple. Often, it lessens those IT conversations and things like that, because we're not using your network; it's not tied into it, right? And of course, there is security concerns and things like that we need to address even with cellular. And the second is because most people, and this is very understandable, you want to start with a pilot. So I want to get a system in or a couple system ins, prove the value, look what I can do, run it up the flagpole, and ask for more funding. So this often, in terms of that time to value with a pilot, really speeds that up. Now, so let's talk a little bit about the sensors and these single point lubricators. So it's a modular system. So each OnTrack is capable of monitoring 16 bearings. So we can have 16 sensors per OnTrack unit, as well as 16 single point lubrication devices. So 16 sensors and 16 single point lubrication devices, which means you can have a bearing that is completely monitored and remotely precision lubricated, or you can have a combination. So it doesn't mean that every sensor has to have a single point lubricator. In fact, they can be added after the fact. So you can start with the sensors and add the lubricators later, or you can have 6 sensors with the lubricators and the other 10 do not, right? And it's really designed to scale. And we have customers that start with all 16, start with multiple units, and we have customers that start, I just want to start on one asset. So a typical motor and say fan, two bearings on the motor, sometimes 2 bearings on the fan, 4 sensors, 4 lubers, and that's their pilot, which is great. Now, when it comes to viewing this information, and this really goes down to the simplicity and the affordability that we were talking about. And when we design the system, one of the first feedback we have is we need to start getting away from bulky software installations. So when you start using our UE Insights, there is 0 software to install. 0. In fact, we took it a step further and said there is 0 apps you have to install. So if you want to get this information on your tablet, on your cell phone, you do not have to go to the iTunes store. You don't have to go to the Google Play Store. It's all web-based, which means if you have a device that is connected to the internet and it has a browser, so Safari, Google Chrome, Microsoft Edge, Internet Explorer, if that still exists, right? You can go out there and you can access this information on any device. Given you have the right security credentials, right, you can access this, and that dashboard gets automatically optimized for the device you are on. So you're in a meeting room and you want to show people this is the status of my bearings, and you have typical conference rooms in facilities have a PC that's always presented up to that big screen TV. Log in there. You're at home, use your home computer, right? You can access this information anywhere. There is 0 software to install. So let's talk about how this system really comes together. Now, in this example I'm going to show you, it's showing 4 bearings, right? It's a typical motor fan combination, right? But the OnTrack is capable of 16 bearings. So in this case, we install our UltraTrack 750 sensors on these bearings. Now, they do get hardwired back to the OnTrack unit, okay? So it is a wired system from the bearings to the OnTrack, right? And we really designed the system to be edge analytics, which means it gets next to the assets or class of assets that's being monitored. So think cooling towers, air handling units, distribution pumps, things like that, right? So the UltraTrack 750 sensors get installed, and I will cover that in more detail, and hardwired back to the OnTrack unit. The OnTrack unit does require power feed, so it's a typical wall outlet you would plug in. It's a very adaptable power supply, so anything from 110, 60 hertz up to 230, 50 hertz, right? So this can go in pretty much any world area. And it covers all the power distribution and power conditioning to these sensors. So you don't have to run any other power to the lubers, to the sensors, or anything like that. We try to limit the cable length coming from our sensors to 100 feet. The reason we do that is that's what we typically stock, but we can go longer than 100 feet, but I would challenge that it might make more sense to put another OnTrack in it than it is to go over 100 feet. And we can discuss that more if you have specific applications in mind. So that 750 sensor is monitoring that friction in that bearing. That's essentially what we're trying to do with the bearing. Friction tells us when we need to lubricate, and friction tells us the health of that bearing. So it's monitoring that, and the OnTrack is capturing that data, and it's going to send that data out either cellular, Wi-Fi, or Ethernet to UE Insights. UE Insights is turning that data into insights. It's looking for, do I need to lubricate? Do I need to do other things to help prevent failure of this bearing? So it is a passive system. So it means you don't have to sit there and look at the dashboards. While the dashboards are great, they're very intuitive to use, and they're quite interesting having them up all the time, looking at this real-time friction and health of your bearings. It is going to notify you. So in this case, say 2 of these bearings require lubrication. It is going to send you a very prescriptive alert saying this bearing requires lubrication. It's not going to send you a bunch of squiggly lines and a bunch of other things that you need to interpret. So even if you have non-technical people or people that are just entering your industry that might not understand ultrasound or bearings, it becomes very descriptive at this point. This bearing requires lubrication. Now, at this point, you have some choices to make. Obviously, this bearing requires lubrication. You can go lubricate that bearing yourself using a grease gun, using your cell phone, watching that real-time friction, or you can now use this Smart Lube feature, which is either a manual or automatic way of sending grease to those bearings. So what UE Insights is going to do is use that proprietary algorithm that's been designed specifically for ultrasound guided lubrication best practices to properly and sufficiently lubricate that bearing. And what we've done is make sure that we use the grease only when required, and making sure that we do not over grease those bearings, right? So there is unique checkpoints in place to make sure that we never over grease those bearings, and we will get into that in more details. So you can start to see the simplicity. You can monitor your bearings, the friction in your bearings from anywhere, and at any point in time from anywhere. Even if you're in your plant, you still don't have to leave your office or your workshop, right? Or if you're at home, you can still lubricate these bearings and get that real-time information like you're standing next to those bearings from anywhere. So some of the key features is we really look at this as a remote lubrication assistant. It is watching your bearings 24/7. It's going to notify you the moment that it sees that friction start to change. And essentially, we've lost that thin film on the rolling elements that is required, that lubrication solves, and that lubrication is required. So we see that change in friction. We're not damaging the bearing at this point, but we are starting to see that friction increase, but there's no damage to that bearing. And that assistant is going to say, you need to lubricate this bearing. And then what it's going to do is, using friction as its guide and these ultrasound best practices that we're going to go review, it's going to start lubricating that bearing for you. Now, what we do is we create a bearing and lubrication database. So you enter the size, you enter all the information about that bearing, including, if you've ever used them, there are calculators out there to calculate the theoretical lubrication interval and amount. And there's a reason why we want to still use that feature. And if anybody is a little hesitant on shifting from time-based to true condition-based using ultrasound, those numbers can help give the confidence to start extending and using less grease over time. So what we can start to say is, hey, normally you would have greased the bearing at this time, right? Why don't you go take a look at the friction? Try to push it out a day or a two or a few weeks, but keep monitoring that friction. So you can still set alarms saying normally you would have lubricated at this point, right? Do you still want to go lubricate, or can you trust the system? Can you trust the friction is going to be a better guide, right? And what we do is, after every lubrication cycle, we calculate the insights that are typically calculated for a best-in-class lubrication program. Really try to help you optimize and improve your lubrication within your facilities. So what we're going to do is we're going to calculate automatically the amount of grease that was used, the amount of time that it was taken, who lubricated it, when it was lubricated, the resulting change in friction. Because these become very, very valuable insights that we can start to track and trend over time, right? When you start to get that ROI from using this type of systems, right, it's not uncommon for us to see at a minimum a 30% decrease in grease consumption. When you start adding up all your grease, that could be a really valuable ROI or payback right there. Now, we do have 2 modes. We have the manual and automatic greasing modes, but you are complete control. It's not going to just go out there and start randomly lubricating your bearings without you knowing. You have to give it permission to do so. And with all things, we want to learn over time. We want to learn specifically this bearing, this application, its grease needs, all that type of stuff, to be able to help optimize and create that ideal lubrication program moving forward. Now, the next one fits into the openness of the system. So what our customers have asked us in this beta is, this is great, it's going out and lubricating, but I still need to do that paperwork saying that this bearing was lubricated and all that kind of stuff with that information. Can you tie this in to a CMMS or ERP system? And we absolutely can, right? Now, often, because some of you might have large facilities, SAP, Infor, those type of systems where integrating is a project on its own, that's probably going to consume a lot of resources. So it is completely optional, right? But we do have the ability to automatically create work orders and pre-populate this information. So consider that down the road if you do want to go down that path. So in terms of simplicity, right, as I said, we really designed the system to be simple. So many of you are already using our technology, and we thank you for that. But essentially what we're doing with ultrasound when it comes to monitoring bearings is we're measuring friction, right? And why do we want to measure friction? Because first of all, it is the only condition that is used to measure the lubrication needs of that bearing, right? And it's also, and if you think about it, as a bearing starts to fail, now whether it's an individual ball bearing in this example or an inner race, outer race defect, you can very accurately link the increase of friction to the rate of that bearing starting to fail. Now it is exponential, it's not a linear curve, right? But it does give us a good indication of when we've passed that lubrication failure mode and how quickly we're starting to fail, right? Now I don't want to get, we can often get in debate, and you can see this all the time on different forums of what technology is best to detect the early onset of failure, right? And it really depends on your application. And we often see and encourage ultrasound to be used with other condition monitoring technologies as well. As I'm sure many of you would agree with that. There's not a magic 8-ball that if you use this one technology, you would catch all your failures, right? It really depends on the failure modes and things like that. But what we generally see is specifically for bearings, and this is a study going way back in the 70s, but it gets repeated by academia and industry, is that change in friction is you'll see that before a change in vibration or temperature. So when we think about this from an anti-friction bearing, and the enemy is right in the name. It's an anti-friction. You're trying to reduce friction. Now, the good news for us is there is always an inherent level of friction, and that's what we're trying to maintain, that optimal level of friction. But with a facility having, as I mentioned, 2,364 bearings, I think it was, right? It's not really our lack of knowledge or friction that is the problem. It's really time, right? Because as I mentioned, there's a lot of certifications out of there. There's a lot of great training programs out there on managing your lubrication needs of your bearings, but often we just do not have the time. And what I say is that, even if the two bearings are the exact same type on the exact same machines, is those bearings probably didn't get manufactured the same way, they didn't get installed the same way, they haven't been treated the same way in operation. So each one does require a little bit different needs. So here's an experiment. So what I'm going to do is, in the sentence below, is get you to count the number of Fs. Okay, I'm going to give you 5 seconds. 3, 2, 1. So here's the reality. You're going to have an answer between 3 to 6. Now, if you had 6, you got them all right. Now, when I did this myself, I counted 3. And what did I miss? I missed the 2-letter words OF, right? Because some reason our brain just doesn't think that way. Now, some of you might say, I got 6, and good for you. And some of you go, I got 3. It's not a reflection on your ability to know what the letter F looks like, right? It's just that we have other competing priorities in our life, right? You could have been daydreaming right now on another page on this webinar, go, he wants me to do something, right? Or, there's different challenges we're going to have, right? And the same thing can be brought down to bearings. We know ideally what we should be doing. We just don't have the time and focus, right? If all we said is, and if your boss came to you, or you happen to be in charge of these bearings, and you said, okay, I have one person in charge of 5 bearings, and that's all he does or she does, 24/7, then yes, I'm very confident that you can maintain those bearings perfectly, right? Just like our job is not to look at the F's in sentences, right? We know what an F is, but that's not our dedication, right? And that's really where the OnTrack Smart Loop comes in. And here's the other issue why time is the enemy. Now, I do believe, and I was a fan of these back when I used to operate equipment, I used these calculators all the time. In fact, I never actually got into how the calculation was done. I put in the variables and trusted the calculation of the results that came out were accurate. And I think it's time we look at these time-based lubrication frequencies. So this happens to be one calculation. There's many calculators out there, often resulting in somewhat similar numbers. But if you look at the complexity of these formulas, even just look at something as simple as speed, right? How many of us have motors that don't operate at a constant speed, right? And I think that number is only going to increase over time, right? As people start to redesign process control for energy optimization and stuff like that, you're starting to move away from control valves, moving to variable frequency drives, variable speed drives, those type of things that have different operating speeds. So those of you that are in pharmaceutical and things like that, you'll understand this really, really well. Even in distribution and things like that, it's very difficult to operate things at the same speed. So that speed, that N, can have a huge influence on the time-based lubrication frequency and quantity, right? Now, people have started to address that by putting duty cycles into these calculations and things like that, but you're still making an assumption. And even look at these correction factors. Say temperature. Temperature, if your housing was, say, 151 degrees F, would you, in that calculation, use a correction factor of 1 or 0.5? Right? You're at the very low end of that 150 to 175, right? In fact, you should probably be using like 0.9, 0.98, 0.7, right? So those variables often are assumptions. They do not reflect what's actually happening in our environment, in our operating conditions, which of course, we've all seen it leads to over greasing. In most cases, sometimes these calculations are great and they work very, very well. Right. So what we did is we took an honest look, and we actually even threw ourselves under the bus here a little bit, was we looked at the two lubrication practices. So there's time-based and there's condition-based. So time-based, just walking around with the grease gun, does not address any of those four categories that SKF was mentioning. Now, what we've seen, and we've seen this with the rise of COVID and talking to these single-point lubrication or distributions, these what called auto lubers, has been a significant increase with the purchasing of these units. Now, if you look at it holistically, they are very, very good at making sure you use the right grease and is contaminant free because they are sealed units pre-filled with the correct grease, right? So every time that is going, typically on time-based, it's going to dispense that right lubricant, typically contamination free, right? So very, very good at solving those two problems, but they still are time-based. Now, there has been some progression with technology with integrating vibration sensors, so it helps to make sure that duty cycle is in that calculation, so it can start to track how often it's running. And what it does is it makes sure that the equipment is running when it's lubricating. But the reason why there's a vibration sensor in there is not to track the condition, is to make sure that it knows that machine is running. Right? So it's not doing it still based on condition. You still have to program a time interval into it. So then we move over to condition based. And so we've had the grease caddy out for a number of years, over a decade, right? Really designed for purpose. But because you're attaching it to a grease gun, you still have the risk of contamination. And the way it got described to me was, Blair, have you ever seen a lubrication technician wipe down a Zerk fitting? Right, or clean the grease gun, and chances are I never made note of it, but there's still potential to mix greases and provide contamination. What it is really, really good at is making sure that you lubricate with precision, you know exactly when lubrication is required, and use the precise amount of lubricant. Now, typically we see this being used on a month basis, so you might, there's always the issue of not capturing the lubrication need right when it needs it. Right? You could be, if you do it on a month basis, up to 30 days apart, right? So that's really where the OnTrack Smart Lube came in. We wanted to make sure, we can't say eliminated because there's always a possibility you install the wrong lubrication, the wrong grease in the luber and things like that, but we wanted to significantly reduce all four of those categories, but be able to do that all remotely. Right, and if you use our technology, this is something that you would very well understand. It comes out of the ISO standard in terms of what we do is set a baseline. Now, these baselines, we could have a webinar just on these baselines alone, how we set these baselines, because the reality is what we say is you set a baseline on a healthy, well-lubricated bearing. But many of you on this call are saying, listen, I have bearings that have been spinning in a circle for years. I have no idea the condition. They've likely been over lubricated. How do you set a baseline? And there is a process to be able to do that. And that process, if you've ever done it, have done it with manual ultrasound using our ultra probes or a grease caddy, doing it with an online system becomes so much easier because we have more data. And specifically with the smart loop, we can actually give it a little bit of grease. Did the decibels go up? Did they go down? Right? So we can start to create those baselines a lot easier with this system. So let's say we have a baseline of 10 decibels, and I'm making that number up. When we see a change of 8 decibels, so 18 decibels that bearing's now reading, is an indication that that bearing requires lubrication. So when the OnTrack gets that information, it's going to send you that. It's going to give you the quantitative information. At this point in time, this bearing increased by this many decibels, but it's going to give you that very prescriptive alert that I've been talking about. This bearing requires lubrication, right? Now, it's not always 8 decibels. If you do have a variable frequency drive, we want to make sure that we cover the entire operating range. So on a healthy, well-lubricated bearing, the change in speed does not impact the friction or the decibels very much. We can see a change, and we've seen this, and we can actually show you, if you want to book a live demonstration after this, we can show you, Chris and I can on a call, we can show you what a bearing looks like on a bearing that operated, I think it was like at 100 RPM, and it went all the way up to 1500 RPM. And it was well lubricated. The change in friction or decibels throughout that entire speed range was around 2 to 3 decibels. Right? But if that bearing had a defect, we obviously see that increase in friction gets magnified, right? So it becomes very easy to set these alerts. And we see a 16 decibel increase indicates we've gone beyond that failure mode, that lubrication failure mode, which is interesting because with this live system, what we can do is we can still grease that bearing. We'll see a temporary drop in that friction, but if there is a fault in that bearing, we are quickly going to see that friction come back. And I mean quickly. And we have live examples of this. And this really what makes this product unique is that customers that have put this in have loved this product so much that they've given us permission to be able to share their data. Now, these are typical, private or open type companies like a teaching university and things like that are willing to share their data. And we thank them for that. And then when we see a 32 decibel increase indicates it's close to failure. So this is an example of the prescriptive alerts that we're talking about. And you can see here, in this case, this example, this is before Smart Loop. The first thing you get is alert description, lubrication required, right? In fact, what we've seen our customers do is when we design this, we said, oh yeah, we want to make sure you can customize your alert. So lubrication required. You can send it to a planner and scheduler, right? Lubrication required, please create a work order to lubricate bearing XYZ, right? What we started to see our customers do was actually put the grease type. So they started to manually try to address that, one of those categories, which was using the wrong or unsuitable grease type. So they tried to help eliminate that by putting the grease type in. I thought that was great, right? And that really came from our customers, not from us. And then when it comes to being able to view these insights, so what we use is our UE Insights. And we have a number of these widgets that you can build your custom dashboards with, right? This happens to be one I'm very, very fond of because what it allows you to do is be able to view the lubrication needs and health of your bearings very quickly and easily. We've had customers create hundreds of these widgets and just be able to keep them on one dashboard so they can quickly look up and see them all, right? So in this case, the baseline was 26. Right, 26 decibels. Right now, we are reading 28.7. We are taking a 10-minute moving average, which is customizable in the UE Insights platform. We recommend 10-minute moving average versus taking that instantaneous 1-minute reading, but it can, of course, can be changed based on that application. So it's reading 28.7. That arrow is in the green. It means do nothing, right? This is ideally where you want to see all of your bearings. Now, let's say that reading was actually reading 36 or 38. We were in that blue zone. Indicates a lack of lubrication. Now, this is a very important feature. The data we are capturing from that bearing is real-time friction. Yes, we save all, and I mean all of the historical information, but it's real-time. So let's say that arrow was in the blue zone. And what you did is you walked up there to that bearing using a grease gun, making sure you wipe down the fittings, making sure you're using the right lubricant, and you went to lubricate it using a standard grease gun. You could walk up to that bearing using your cell phone, using a tablet, and have this gauge pulled up and start to lubricate that bearing. Every time you squeeze the grease into that bearing, you're going to see immediately the resulting change in that friction. So imagine that arrow was in the blue zone. You start to squeeze the grease gun, that grease hits the bearing. You might actually see a small little increase while that grease starts to get distributed, and then the arrow starts to move to the left. You put a little more in, moves a little to the left. You put a little more in and moves a little. And now I'm in the green zone. If you get that bearing back to 26, right, that baseline means you have sufficiently lubricated that bearing. You have done a great job at lubricating that bearing. Now you've done this over your cell phone. You can have someone back in the office watching you while you do it, right? This is the power of that system. Now let's just say if you're new to lubrication and for some reason, I want to get that friction even lower than baseline. Not a good idea. What will happen is you continue to put grease into that cavity, you're actually going to increase the friction of that bearing. And what happens here, again, we do have a system that we can actually test this on. It's quite neat to see. So you start to start to put more grease into that bearing. What we see is a very dramatic increase in that friction, more accelerated than the rate at which you dropped it. So we'll see that arrow start to quickly go past the green, quickly go past the blue, and we end up in that yellow zone, which is true. We are beginning a failure. We have over lubricated that bearing. We are causing too much friction. It's going to cause heat in that bearing. It is not a good thing, right? And if that arrow is in that yellow zone, indicates we've gone beyond a lubrication failure mode, right? Again, I'm not so concerned about the absolute number at this point. What I'm looking at is how quickly is that arrow moving to the right. I came in today and it's at 6 or 56, and now I'm already in the red zone. That's a good indication of the life of that bearing, right? So very easy to be able to interpret the lubrication needs and health of your bearing using real-time friction, right? So we covered, how this system is being used. This is an example of one of our customers happens to be in the pharmaceutical industry, and this is really what set off the Smart Lube initiative, because what we've been able to do up until last week was we completely eliminated the need to go out there and capture data, that friction, that ultrasound data from your bearings, right? But when it came time to lubricate, you still had to go out there and lubricate. And this is an example. We got really excited, and our customers got really excited. In fact, we couldn't keep up with the demand of customers wanting to pilot this because of this. I mean, I don't need to carry a grease caddy, and we're not here to replace your Ultra Probe or the grease caddy, right? This is just an added feature. And so what we saw was customers starting to use it for like this, getting their lube technicians, getting reliability engineers, getting maintenance people, operations to be able to properly lubricate, which was great, right? And we do not limit the number of devices that can access this data. So I'll say that again, we do not limit the number of devices, right? We really want people to use this. So it's not like you have to buy a different seat or different license for each technician and things like that, right? Which really comes down to that affordability. But the challenge we got, and this is a good example of this, because as most of you know, when you lubricate a bearing, you need it to be spinning, right? And you can see here, this happens to be a cooling tower. Now, many of you have cooling towers and starting to think, yep, right? What did you have to do if you had to bring those lubrication lines outside of the cooling tower so you don't get your head chopped off while you're lubricating, right? Or you went to these automatic lubrication devices. So the next challenge we got was, how do we stop this person from going out completely to lubricate this bearing? Essentially what we wanted to do was automate his left hand, which we were able to do now with the Smart Lube. So just by using ultrasound guided lubrication practices, as I mentioned, we've seen tremendous benefits come from these systems. And we've seen, I would say at a minimum, grease consumption reduced by 30%. We have seen customers go 300%. It really depends how much you are over lubricating your bearings to begin with, right? But really what we wanted to get was from here, same guy, now sitting in his office on his tablet, on a computer, being able to lubricate. And in this case, he's watching that real-time friction while the system automatically goes and lubricates that bearing, right? So from a safety need, from all these other concerns you have, access, right? You can properly lubricate your bearing from anywhere. So what we've done in UE Insights is we've created specific widgets specifically for lubrication. So the first thing and the first feedback we got is we've talked to customers saying, do you use these automatic lubrication devices? And what we found generally was a love-hate relation. Some people loved them, some people hated them, right? People that hated them was for two reasons. One is, yeah, they were over lubricating my bearing, so I threw them out. But it might be better than not lubricating them all. It gives you a little bit of peace of mind. I disagree with that, but some people still use them. Hey, it's better the devil you do than the devil you know, right? So, and the other thing we got was, well, Blair, I used them, but I had no feedback. So I ended up having to do a PM on a system that was designed to eliminate the PM to lubricate. So what we found was, well, they would run empty or they would fall off, get disconnected, and they thought they were lubricating and they were not. So the first thing we did is we control every movement and we know the real-time feedback from that system. So let's just say you had a system out there and for some reason you disconnected from the bearing. You lubricate, hey, the friction didn't change. You do it again, the friction didn't change. An alert, something is wrong. Unfortunately, you need to go check that bearing. And of course, you get to a low grease level, it's going to send you an alert, right? It's going to say, hey, this is getting to 10%. Right? You might be able to get one more grease cycle out of this, but you should probably replace this cartridge. And then when it comes to actually lubricating, as I mentioned, you get real-time insights. The amount of grease that's been used in this lubrication cycle, what your baseline is, where you start at, what you're currently at. And if you put it into what we call Smart Lube Assist, you can see these numbers change in real time. It is literally like an assistant to you going out there and lubricating it, and you can just sit there, grab a coffee, and watch it do its thing. So what we found is generally about a 95% reduction in those non-value added bearing lubrication tasks, right? Making sure you use the right grease, putting one foot in front of it or going and walking it, getting permits, documentation, all that kind of stuff, right? And we're not here to obviously replace lubrication technicians, oilers, whatever you want to call them, right? We're really here because they have a very unique scale set that is absolutely needed with the OnTrack Smart Loop. What we're trying to do is make their job easier and more effective. So one of our customers in the pharmaceutical industry, I think, said it best. He was a beta customer of ours, testing this out, really helping define what this product looked like. And really what it comes down to is the benefit of not having to physically attend a bearing, right? What does that do, right? So what did our customers see? On average, a 30% decrease in grease consumption, a 95% decrease in the time required for optimal bearing lubrication. And that's the key, is we're still doing optimal bearing lubrication. And to date, and I expect this number to go up, is we have seen a 65% decrease in premature bearing failure because of proper lubrication. Now, the reality is, failures don't happen overnight. So that's why we're still waiting for some numbers to come in and to be able to compare them what's happened in the past, but we expect that number to go up. So for the first time ever, we're giving you remote bearing lubrication certainty. We know precisely when lubrication is required. We know exactly how much lubrication is required. You lubricate using the correct grease every time, and you eliminate the potential for foreign material to be introduced. So a question to you is, how much time and resulting money could you save if you had a bearing lubrication assistant for every specific bearing, sitting there, listening to friction, ready to lubricate, storing that data, constantly learning, right? How much time could you save? And when it comes to openness, and I'll cover this quickly, and there may be more questions, and I encourage you to reach out to Chris to go over your unique application you might have, is we can send this data. We have Modbus, BACnet, RS-485, open REST APIs to get this information out, right, to CMMS systems, DCS systems, right, all that type of information. It is designed to get out. Now, if you do want to use the Smart Loop feature, that logic is built into UE Insights, so you do need to be able to use UE Insights for remote lubrication. Now, when it comes to affordability, as I mentioned, it's edge analytics. We really designed this to be next to the equipment that's being monitored, right? A lot of the affordability comes from the sensors. Now, a lot of you might already be using our RAS sensors, our remote access sensors. They look somewhat similar, except there's more electronics into them, because when you're using a RAS sensor, you're using the electronics, or essentially the brains, in your UltraProbe, or in this case, all of that is built into these sensors. So they're very, very, very small. And if you do book a meeting after this, we can show you live what they look like. Very, very small. And it's completely stainless steel. It's made for IP67, so outdoor applications. The way I describe this, I'm here in Canada. We have them in our mines in northern Canada. I jokingly say next to Santa Claus, and we have them in extreme environments in a crane in Dubai, in industrial steel mills. Right, they are designed to last and maintenance free. So there's no battery to replace. There's no sensitivity adjustments. They are factory sealed. Right, so there is zero maintenance on these sensors. When it comes to mounting them, we can go over this and we can show you how to do it live. It is a stud mount, a very, very small stud mount that gets epoxied to the bearing. That 10 to 15 minutes it takes to dry, you'll have the entire OnTrack up and running and sending data, right? This is probably the most cumbersome process, but once installed properly, it is set there for life. And we do have a thermal isolation device. If you have a bearing that runs really, really hot because of some of your applications and we exceed our temperature limit of that sensor, we have these thermal isolation device, which still provides a very great repeatable signal, but allows us to stand off, use the ambient air to cool it down so we don't burn the electronics. We have not yet found a bearing that we cannot monitor. And to give you an idea of what the sensor looks like, now it's hard to get scale. This is the cooling tower that the guy was lubricating in that picture I had shown earlier. So this allows me to show two things: what the sensor looks like, completely stainless steel, how it gets mounted onto a bearing. Now, because we're monitoring friction, we're using ultrasound, which is very directional. We just have to be mounted somewhere on that bearing. We're not measuring movement, so we're not concerned about different axes, which is one of the biggest benefits about ultrasound, is that it's very directional. And as you can see here, the cable itself is not in any conduit. It's not in any kind of seal tight or anything like that. So what we designed is this cable for outdoor applications to be run in cable tray, or in this example, be cable tied to the structure, this lubrication line. It is completely shielded from the tip of the sensor all the way back to the OnTrack. So even if it goes over top of high voltage equipment or other mechanical equipment, it is not going to pick up any other noise other than that bearing. Now, when it comes to this lubricator, you're going to have a lot of questions about this, and I can't cover everything, but it is, first of all, it comes in two sizes, so 125 and 250 cc replaceable grease cartridges. It is a microprocessor controlled. It is precise. Every time you tell the OnTrack to dispense lubricant, it is going to give exactly that quantity every time. It is battery powered. And this might become a little confusing because I said you have to wire the unit back to the OnTrack, right? So typically our customers pull the sensor wire, and it's just a standard 2-wire cable. Really, the OnTrack is controlling when and telling it when to lubricate. But the way the lubrication device gets powered is through a battery, and it gets replaced every time you replace that grease cartridge. And the reason we went this way is it really makes sure that we didn't have to, have a big power supply to control 16 of these things in the OnTrack unit. A simple, small lithium-ion battery is enough to power this lubrication device, and is guaranteed to last as long as the cartridge itself. In fact, the battery specs is well over 10 years, because if you think about it, this lubrication device is sitting there in a passive state, waiting to lubricate 99% of its life, right? As I mentioned, the sensor itself is saying, bearing, do you need lubrication? And the lubricator itself is saying, do I need to lubricate? Do I need to lubricate? And it's just sitting there. When it's called to action is actually when it starts to move that motor to dispense it. That's when it's going to draw power. So every time you get a replacement grease cartridge, you get a new battery, new O-rings, and everything that with it. And it's designed to be contaminant free. There's O-rings and gaskets everywhere. So it's really designed to make sure that nothing gets in from the outside of melons into this. Now, when it comes to this lubricator, it produces over 200 psi. Now, if you've used lubricators, this is a pretty high number. So we can remotely mount this up to 20 feet, and we can provide all the fittings and hose and everything you need, or you can get it yourself, right? But we can remote mount these up to 20 feet. At 200 psi, we can push that grease all the way through it. Easily replaceable single-use cartridges. We have hundreds and hundreds. We've partnered with a company to supply our lubricant, and it's going to. Many of you are asking, can I fill this up myself? It is designed to be a single-use cartridge. There is nothing stopping you from filling it up yourself. I can tell you that. But what I would challenge is, since the partner of ours is one of the largest grease providers. Is obviously there's a huge economies of scale there, and often we can provide the kit, the cartridge, the battery, the O-rings cheaper than you can refill it yourself. But there's nothing stopping you from doing that. And as you can see, minus 40 to 60 C, we can go in some pretty harsh environments. So 5 simple steps. When it comes to setting up this OnTrack, we do not simply, give you an OnTrack and say, good luck, let us know if you get some results, right? All the way from the design phase. If you're concerned about how much hose do I need, where I need to mount this, where should I put the sensor, all that type of stuff, we are here every step of the way. Obviously remotely right now, but pictures and real-time calls can get that done. It does have to be installed. Obviously, there's wires to install. You have to install this on the bearings and stuff like that. But when it comes to setting the baseline, monitoring, and lubricating, we are here every step of the way. If you give us permission, we can have access to the system. Just read only. We can never lubricate without you. You have complete control of our access, but we are there to set the baselines, to monitor. The first time you're going to lubricate, get us on the phone. We can see, no matter where we are in the world, exactly what you see. So when it comes to UE Insights, the first thing it allows us to do is, obviously manage all of our OnTrack units. You have complete control. So you control all the access, who has access to it, any updates, change sensor names, and things like that. And it's really in your control. So what we do is we give you a dashboard that we think is really neat, really cool, but you may not want to see that dashboard the way you want it. You have complete control to change dashboards, create your own, how you want to see this data. And it was very interesting. We have seen some very creative dashboards. And what we learned was that no two people want to look at the dashboard the same way, whether it's different job types, different functionalities, different industries, right? You get to create dashboards specifically how you want to see the data. We're not telling you how you need to see it. Now, of course, security is a big concern. So what we've done is allowed you to create a hierarchy. So, the typical child-parent relationship or parent-child relationship in terms of this is the, this is my asset, this is the components on it, but also from an enterprise or plant location. And you can assign users to different parts of these plants. What it allows you to do is if you have someone that's only working in this part of the plant, you can assign them to that area. So when they log into UE Insights, they only see the information that they are supposed to see. They don't have to shift through other data. And of course, you can give them different access. We have a min, read, write. And for those fiddlers out there that like to press buttons, we have a read only, right? You can't do anything except consume this information, right? Great for people that like to push buttons and test things out. And as I mentioned, designed specifically for lubrication, we have widgets that are available specifically for lubrication. Now, when it comes into the 2 modes, we do have 2 modes that allow you to remotely lubricate. The first one is Smart Lube Manual and Smart Lube Assist. And I'm going to walk through both of these. So in Smart Lube Manual, it is a button. What is going to happen when you push that button? There is additional security measures. So just in case you left your screen open, things like that, you cannot accidentally lubricate your bearing. If you accidentally lubricated it, you hit a bunch of buttons without reading the text, essentially, right? So you're going to have to enter your password in again. It's going to say, are you sure you would like to lubricate this bearing, just to make sure that nothing accidentally got hit, right? It's going to automatically start that lubrication cycle, begin to track every movement of the friction and that single point lubricator. The OnTrack by default does capture data, that friction data from the bearing every minute. Now, if you're doing route-based, typically on a month, that's already 1,440 times more in a day. But when you're lubricating, that minute could seem like an eternity because you're waiting for that friction to change and things like that. So we built this by design. So what we can do is put that specific sensor into 1 second update. So no matter where you are in the world, it is like you're standing next to that bearing, capturing real-time friction. So what happens there? Lubrication gets dispensed. That precise amount of lubricant gets dispensed, and you have to watch that resulting change in friction to ultimately make the decision if you want to put more lubrication into it. And then when you're satisfied with the results, you end lubrication, and it's going to calculate all the grease that was used and all that information I've been talking about. The reason we have this feature is because there are certain points in time, and you can disable it, not have the button on it. There are certain points in time when you want to not have those limits in place. When you might to purposely overgrease a bearing, and yes, there are times when you may want to do that, particularly when it's failing. If you want to get another hour or another day, sometimes adding lubrication can help nurse that bearing. You know it's going to fail, but you're trying to limp by, if you will. So you have complete control, no different than you would have with a grease gun, except you don't need to have to go out there and do it. A lot of effort, design, feedback, and testing went into what we call Smart Lube Assist. So the first thing we wanted to do in this automatic mode is make sure that we never, under any circumstances, over-grease that bearing. So the first thing we're going to do before any grease gets entered in that bearing is check to ensure that there is a need for lubrication, right? The other check we're going to do, and this is why we enter or calculate those specific bearing parameters, we will never let the system, regardless of the friction, exceed the maximum bearing capacity. So even if the system could not get that decibel down, it is never going to exceed the maximum bearing capacity. And we're going to ensure that the decibel level did not increase compared to the previous reading. So there are times when we can never get it back to baseline because of known defects in the bearing, and we start to see that decibel increase. We didn't get it to go to baseline, but it starts increasing, indicating we're starting to fill that cavity. It is going to stop there. It's going to say, well, I tried to get it down to baseline. I couldn't. I got as close as I can. Then I started going up. I stopped there, right? So what's going to happen is you're going to receive a notification. This bearing requires lubrication. You're going to say, yes, it does. This asset's in a steady state. I would like you, assistant, to go out there and go lube it. It's going to do the exact same features. It's going to start the cycle. It's going to put in one update. But really what it's automating is that monitoring that change in friction. So if it's done 3 rounds and there has been no resulting change in friction, something is going on. That luber is not dispensing it, right? Obviously, you would know if it's out of lubricant, something is going on, flag, stop, right? And it's automatically going to go through that process. At any point in time, ideally, we get to that friction back to baseline. You receive confirmation saying, I was able to lubricate this bearing. I got it down to baseline. Great. If it happens to stop from one of those 3 reasons, it's going to stop there and send you a notification. I tried to get it to baseline. I couldn't get it quite, and this is the reason why I had to stop, right? So this is really where the value comes in. So what we did is we envisioned what a day would look like, right? And of course, your day is not just using Smart Lube, right? It would be nice if it was, but it's not, right? So what we pictured is, you come into the morning, overnight, a bearing came in saying it needs lubrication. You go in the morning, say, okay, yeah, I can grab a coffee, log into UE Insights, start to lubricate, right? Hit that Smart Lube Assist. Go get a coffee, do other things. You can have it on another screen or hidden behind another screen, and you can check in every now and then. It may take 45 minutes for it to properly lubricate a bearing because you're not out there doing it. You don't really care about time. Ideally, you get confirmation that it was able to successfully do it or reasons why it didn't, and you can go finish your coffee. So again, the only system out there, every aspect was thought about this and tested to give you remote bearing lubrication certainty. So when it comes to purchasing or getting one of these, we do have purchasing or subscription. I'll love it or hate it. We didn't want to lock customers in to either or. You can buy it, you own the equipment, or you can essentially pay a monthly fee to use the equipment. What we've also done is created a pilot kit. So up to 16 sensors, up to 16-point lubrication device, everything's pre-configured, your specific grease. We we make sure we build the dashboards, we set the baselines with you. We're there the first time you lubricate, or you want to use our system for the first time you lubricate to test it out. Absolutely. We're here for you through this entire project. In fact, many of our customers have given us read-only access so we can monitor them as well. Also, what we've included from the financial side is a discount, likely till the end of the year, just to help people get started with the Smart Lube system. So what I'll do is, I know I went over here, but I'd encourage you, if you have questions, really seeing is believing. We do have systems where we can show you what this data looks like live, how to baseline. Invite you to take a look at our website that might answer some more of your questions, specifically on the Smart Lube. And reach out to Chris. Obviously, I'm sure, Chris, you'll pop up your email or some information here. If you don't know Chris, reach out to him, and him and I can get on a call, talk about this. If you have ideas, need more questions, please reach out. Love to chat with you.
Okay, well, thanks for that, Blair. I have just a couple of questions for you. I've been quite busy answering some in the question and answer dialog box. If anybody else is having a look through there, answering those up. One question, Blair. Could the units, the Smart Lube units, be filled with a grease of their choice?
Absolutely. We haven't had a grease yet that we couldn't pre-fill, and it's interesting to see how many grease types are out there. And there's grease types obviously in North America that don't exist in Europe and things like that. So absolutely, but with a high level of confidence, we can have that specific grease.
Okay, thank you for that. And the next one is, we've had some questions obviously about having systems that have sealed for life bearings. Can they use this for just condition monitoring of their bearings? I've already answered this saying, yes, we can.
Absolutely.
The next part of the stage is that they then identify a failed bearing, they replace said bearing and start again. Can they input that into the system as an event that they've now replaced that bearing?
Yeah, and that's feedback we've gotten. So in the current revision, no, we do not record an event, but it is in our roadmap that will be released shortly to be able to put essentially in the alarms and events that something did happen. So when you go back and trend it, you can see when you replaced it. So right now what we do is we have to reset that baseline, which is our trigger that something happened that got replaced, but we are adding that to our features list.
Okay. Another one, is this system suited to 1500 to 300 RPM applications, or can it work on slow speed applications as well?
Yeah, great question. There's really no limit on the top end. It's really when it comes down to the slower speed end. And we've seen bearings, less than 100 RPM work really, really well. What starts to be a concern that we have to discuss is what is essentially the torque or load on that bearing. It's not necessarily just the speed, because if you have a slow speed bearing on like a fan that's just moving air, like next to your bed or something like that, there's no load. It generates very little friction. But if you have a slow speed bearing that's on a big drum, a lot of torque, typically belt driven or something like that, we would absolutely be able to pick that up. So I can't give you a hard limit on what it is, but absolutely the system is designed to work on all speeds. We just need to make sure that the application and that friction is going to work. And if you already have one of our handheld products, it's a very, very easy test to be able to do. If you don't, I'm sure we can get together with Chris and work that out.
Yep, thank you very much for that, Blair. I think I have just another quick question. Can this system be used to monitor friction on oil lubricated bearings?
Yeah, and that's an interesting one. So we can actually have grease and oil. Specifically, if you get into journal or sleeve bearings, right? The technology we're measuring friction and impacting, and typically you see those in later stage failures. So typically the standard with journal bearings or sleeve bearings is prox probe, because you're looking at distance, I guess. So it's not designed to give you that early notification. I mean, you could use it, but not designed for that. But if it's like an oil system, you could put it in for sure. And I think that would come down to specific applications that we could talk more about.
Perfect. Thank you for that. I'm just checking now for any more. I seem to have lost my Q&A screen all of a sudden. Good old technology. And can you calculate the remaining useful life RUL of a bearing? So tricky question.
No, it's not, and I love it. And my background is analytics and AI, so whoever answered that, kudos for you for doing that. So what we're doing is we are capturing all this data, and we do intend to be able to use machine learning to be able to predict that remaining useful life. What we found is that friction increase is very indicative of the life, but we cannot have a certain level of certainty with that. So what we do is we track the rate of rise of that friction, which is a good indication of that RUL, remaining useful life. We're not at the point where we have a calculation saying, you have 3 days and 32 minutes to failure. When it comes to remaining useful life, and I'm going down a little bit of a rabbit hole here, but the question is not what is the remaining useful life, the question is what is the likelihood of this bearing failing in the next X period of time. and that's what we're trying. That's what we're working towards to be able to get that using friction.
Perfect. Well, thank you for that, Blair. Well, I think that's quite a good level of number of questions that are coming through here. What I would suggest now is that we call an end to all of our questions. Any questions that we haven't answered, we will come back to you on an email. I'm just going to share my screen now with my contact details, just to let everybody know what to do to obviously contact myself. Hopefully you can see my details with my email address and my contact number. Please feel free to look onto our website. As Blair did say, we can provide online demonstrations of this system in action live. This is a great system that's going to provide a lot of use to a lot of people out there. So please feel free to hit us up anytime. Especially in this current environment with lockdowns impending as of tomorrow in the UK, we can do these things online anytime. Okay, so Blair, once again, thanks for your presentation today. Fantastic as always. And with that note, we're going to call it end to that today. And yeah, look forward to hearing from you all again soon.
Thank you, everybody.
And take care.